Okay, so I guess we can just start. So first of all, welcome to this exam. It should now be available to you online. So the purpose of this meeting is to go through the exam task, so you have the possibility to ask questions about unclarities and those sort of things. Because after this meeting, the only communication will be through the course's issue tracker. So that's why we have this one. So feel free to ask questions while we go along and also afterwards. And if you finish before 12, then you're free to start and you will have time all the way until noon on Thursday. If we should go some overtime because there are many questions, then we will postpone also the deadline on Thursday. So don't worry that you get less time. We will fix that. Okay, so I'll start by sharing my screen. Anybody can hear me, by the way? Oh, great. I also record this. Yes, I'm up. Just send a message to Erik. Ah, okay. Can wait a little bit. Can you hear me now, Erik? Yeah, great. Okay. Then I will start by sharing my screen. So I think I will just share the whole thing because I will zap a bit back and forth here. Note also that I will record this session, so that it will be lying on the YouTube page afterwards if you need to go back and look at things in case you don't get all the details now. Alright, so you can see my screen here. Good. Yep. Okay, so if you now go to the GitLab wiki page, you basically have the exam lying there now. So if this, yep. So if you go to the menu on the right, you'll click exam here, and everything should be available at this page. So you have the instructions for the exam, it's here. You click on that, you'll get them up in a PDF format. You find the resources here, which is quite a big file because there's a lot of objects and things in there and some height maps and those sort of things. You cannot get this, it's not shown, so you need to just click download here and you get this message that they cannot search it for viruses because it's too big, but it should be no problem with this one, so you should be able to download it anyway. So you just click this one. You may just start doing this now if you'd like to, and let me know if something doesn't work. In these resources you will also find the instructions. I will not download it now because it just kills resources. In addition to that, when you submit, you will do that under this link. Now this year we chose what we did some few years back by just filling everything into a spreadsheet because there's been some quite some trouble with these logon systems. So when you wanna deliver, let me see. You can go to this one and just click here and you get up this spreadsheet. Now here you will see your username. So just find your username, whatever that is, and then you paste the link to the repository that you choose here. As with assignments 2, you're free to choose whatever you like, but make sure, and that's important, that you commit more often now, so that we have a track record here. And I also encourage you to fill in this at once. So you start this exam, you start the planning, you make a repo, and you paste the link here at once and make sure that it works. because then you basically delivered. All you have to do right before noon on Thursday is then to make the last commit basically. So then you don't have to worry about things messing up and all that stuff. So I would encourage you to do that at once after we're done with this meeting. And you also see a slot here for the video, which will accompany this exam. I'll get back to that later. You can just fill in that link here as well. And this page will be lying here all the time, so it will not be taken down, you know, after 12 on Thursday. So it will be basically open. And we also ask you in exam to do a self-assessment of this, how you thought you performed. So you can click that one once you're done. And afternoon on Thursday, you will have 12 more hours to do this. It's not that big. It's some questions on how you were able to solve the different tasks, if you were or were not. Unfortunately, some things are in Norwegian here. I'll try to fix that. But this red star means that you have to fill it in. So, for example, your username we need, and you need to answer these questions. But there's an option here to comment on each task. If you, for example, solved it just partially, you can type here and then type in your answer, whatever that is. And at the bottom of this one, you will have the possibility to evaluate the exam. How hard did you find this task? And then comment and write whatever you want here. And then click send at the end so that we receive it from you. But you don't need to worry about that until you delivered. So these are the sort of the steps you have to do. And I think that first and foremost, you have to have the instruction and the resources. And then, as I said, fill in this one as soon as you can. Okay, are there any questions? I mean, you're free to use whatever. You know, you can do like you did in assignment 2. Someone used Bitbucket, someone used GitLab. It's really up to you. Just make sure that we have access to it and so you're able to check it out, right? Apart from that, you're free to use whatever you're comfortable with. So just make sure that you paste that link into this document and make sure that it works. And then it's fine, whatever you choose. Now, it should be available through this spreadsheet, basically. So, because it's a bit different since the exam, it should be connected to this Google Drive here, where we collect everything that has to do about the exam. So just paste it into this Excel file here. So if there are no more questions, I can start to go through the tasks. And let me know if you try to download this while we speak, if it doesn't work, so we can have a look at it, what may go wrong. Alright, so this is basically the task. It looks quite big, but there should be enough in here for, I think, most people to pass this. And I also think that some of you should be able to climb quite high up in grades on this one. But it's really open and there is a lot of things in here, and it's not meant that everyone should solve every possible thing we ask for in here. But I'll explain how to go about. So first and foremost, you can also do that afterwards. Read the entire document again before you start, and then start planning how you would do this. Identify what you can solve right away, what you will need some time on, what research you will have to do, things you very uncertain that you will be able to solve, you can postpone, and those sort of things. But don't get overwhelmed. Try to think that, have the attitude that you will be able to address this. Also another important thing, any questions after this meeting will have to be posted through the course issue tracker and carry the tag exam. I can very briefly show that at once, so I basically done it. So if you go into the GitLab under labels, so it's basically under issues and then labels, you will find this label named exam, and I put it up as a prioritized one. And what you do here is that you subscribe to it. Now I subscribe, so it says unsubscribe, but you make sure you subscribe, because then you will receive emails every time this label is addressed. And anytime you have an issue, you go in here like you have some of you have done before, you make this issue, so new issue, you know, set in whatever you have, you type your comment. You don't really need to do much with these things. I think it's just important that you make sure to connect it to the exam label, because then I will receive a mail once you address this, and all the others who have subscribed to this tag will also receive a mail, right? So this will be the way to communicate after this meeting. Okay. Any questions to that, by the way? Wait, let's see if yes. Okay, and yeah, this exam in combination with the oral exam that is in about a week's time or 1.5 weeks is worth 60% of your grade. Now this take-home component is 35%, so I upgraded a bit from last year's where it was 30, and I downgraded the oral exam to 25. I've done this because, of course, this is a much more involved part of the exam, basically. So 35% of your total grade. You already have 40 from the assignments, and of course you have this oral component, which is 25%. And in this one you will present your work, and about half of that session will be questioning about, you know, theory of the course that you have seen in the lectures, mainly. And we have added this on 25% to make sure that you can, you know, if something goes sideways on the take-home exam, you also have the possibility to gain some points here. And important, of course, deadline, Thursday, 21st of May, 2020, of course, at noon. That is not in the evening, but in the middle of the day. So remember to make your last commit by then. Okay, so here is the exam, just in a general sense. The idea is that you should render a landscape that is based on some grayscale height map. I'll go into details on the grayscale height map when I get into the tasks. Now, the scene you produce should be textured, either textured using some custom texture or you know, sampling the scene along some sensible color to signal elevation ranges on this landscape. And what I mean by this is, I can show you a picture here, is something like this, for example, where you know, the lowest levels are blue, and then intermediate levels are green, and then the highest altitudes are like mountains. They can be brown, white, or you know, whatever color you find appropriate, you know, so some sort of thing like that. Or you could use textures. That's really up to you. So it's really open-ended in that sense. Be creative, and you know, the point is that it should be possible to distinguish elevation ranges. A landscape should have a forest line and a lake. That is already included in this grayscale height map. I'll show you later. And you should allow the user to move freely through the scene. Navigate using mouse and or keys of your choice, like you have done in the assignments. It should also be possible to switch between different perspectives, like first-person perspective, third-person perspective, and also a view from above, which I'll get back to. And you will have several models that you can load into the scene. It should be 3, at least, where you have one that is based on the ground, one that is floating in the air, and one that is in the water or the lake, basically. They should be able to move around on their own or be controlled by the user as a possibility. It's very important here that I provide some grayscale height maps. One of those you probably have to use, but all those models I have given you in the resources, you're free to use them, or you could you know, generate these things on your own, or download some models online. That's really up to you, but I provided some just to give you an idea of what we're looking for. So I'll go through this task by task afterwards, so it will hopefully become a bit more clear. Just a little bit about how I will evaluate this one. You will see here that there are 3 tasks in total. Task 1, Task 2, and Task 3. Now on each task, you take Task 2 here, you have a main part, which is basically the chunk coming right after the taskbar here. So these are the main ones, and then you have these additional features here. So this is a bit like you saw it in the assignments, basically. So what we will ask you to do is to focus on the main parts, and if you are incapable of solving some things there, you may add on points by solving additional tasks. But it's important here that we don't want you to speculate to solve only one main task and then just have a lot of additional tasks. These are there to sort of make up for what you cannot do otherwise, or if you would, make things a bit more impressive. That's really up to you. But as I say here, to pass this exam, you will have to address 2 of the main tasks. It doesn't mean you have to solve them completely, because if you do that, you would get a 2/3 score right, 2 out of 3, as each of these main tasks have the same weight. So to pass, you will have to address at least 2 of them, which means that you should not just take task 1 and then focus on that task and do additional features, but you should have been touching upon 2 of them. But apart from that, it's the same percentage as you would otherwise have to be able to pass. And to obtain a good grade, you need to address all 3 main tasks, basically. Not necessarily solve them completely. If you solve them completely, you should pretty much get a good grade, right? But if you're not able to solve some of the main tasks, you can compensate by solving additional tasks. But it's important that you address all 3 if you want to have a good grade, and not just speculate in picking points on additional tasks here. And of course, obtaining a good grade will also in addition require that the solution is well composed and that the coding is of a professional standard. This is basically what we've been talking about throughout the course, and you have gotten some feedback from Carl and Leon on this. And of course, this is not only important to obtain a top grade. That will be validated in any sense when we look for your solution, for example. So if we say, should you get a B or should you get a C? Well, if you have a nice coding standard, that will definitely count in your favor. So this is important in all respects, all over the scale. But to obtain a top grade, this should be part of the solution. Right, so just like assignments, you have the possibility to make up for things by adding additional features, or they will simply give you bonus points. So the simplest one may give you 5 to 10% bonus points, while the hardest one can be up to 20. And it's sort of loose how much we give here. It depends on how involved you are with it, because it's possible to be quite involved with all of them. So let's say, for example, in task 1 here you have the possibility to generate your own terrain instead of loading the image. Now, of course, if you just generate a flat terrain, you will pretty much not get any points at all. But if you make a really involved terrain, that can give you up to 20%, for example. So it's a lot of flexibility in these tasks. So before I start to go through each task in detail, do you have questions? Okay, then I'll just skip on. There are 3 tasks. One is about generating the scene, putting on basic lighting. The second one is to move cameras and lights, and the third one is about objects. And there's some things I will go through here afterwards, once I've gone through them. So the first task is that you will load one of the height maps that is provided on the resources. So if you have downloaded it, you already have these files available. If not, I will just show them here. So here you'll see many height maps of different locations in Norway. Some of these places you may know quite well. You should at least know this one by now, right? So different height maps, and each of them come in 2 resolution. It's high resolution and low resolution, and depending on how fast or slow your computer is, and you can choose one or the other. Now the point here is, if your solution is a bit low poly and those sort of things, it's not really doesn't really matter that much. What matters is that it's composed and that you have sort of addressed all the tasks. We shouldn't sort of penalize you for your computer or those sort of things. So it's the important thing is that you make this run and work. So just pick one of these, either in high or low resolution. I can click in on one of them just to explain what this is. Yeah. So here you basically see a grayscale image, and black here is basically sea level. So this you can assume is a lake, for example, which you may color blue or whatever color you find sort of like looking like a sea or a water surface. And then the highest ones are mountaintops or highest elevation. So the whiter it is, the higher it is up, and everything else in between is a different height. Now, these are basically three-dimensional data for each pixel. So you have a x and a y coordinate, and you have a z coordinate, which is basically the pixel value. And of course, this will have to relate to the OpenGL coordinate system in the right way. So you sort of like get x, c, and then y is pointing upwards. Okay, so pick one of them and try to make a mesh out of it. And then color or texture the elevation ranges to resemble a somewhat realistic representation of altitudinal zones, right? Doesn't need to be terribly exact, but have something that's distinguishable, like you can see in this map, for example. So you can use blue, green, and whatever color you like up to the higher altitudes, you know, brown, yellow, white, you know, whatever. It's really up to you. And let me see this question. Well, yes, of course, that's a possibility. But it's really what you like, you know. As long as you can differentiate different heights and you know that's distinguishable. And of course, it's always okay that it looks nice. So, but it's that's an option. But you could also have them, you know, like, but it probably looks nicer if it's interpolated. Okay, so you can assume the lowest levels is water, which is black in the height map, and the highest are hills, which you can color from brown to white, you know, depending on whether you want some snow or glaciers on top or whatever. And the intermediate height should correspond to a tree line and be greenish, and here you can have some trees scattered around. So here you may generate trees on your own, but you have also several pine trees provided in the resources. So if you go to the resources, again, you will find, you know, 3 different pines. You have one here that is a bit more detailed. Let me see. Yeah, so this one is one tree. You have some very simple ones also, like a tree fan, which is basically just consisting of a few simple quads. Hopefully it will load today. Ah, there it is. So at a distance it looks quite nice, but if you look at it from above, it's basically very simple, right? So these are very low resolution, so it's possible to place more of them into the terrain and not killing the application, basically. So, but you pick one of your choice. You can make one yourself or find another one online. It's really up to you. But you have some examples here if you like. Right. Important, the height representation does not need to correspond to the actual geographical metrics. It's just that the elevation level should be distinguishable. So the size of this and how you scale it is really also up to you. Then we would like you to illuminate the scene by emulating sunlight at first, just static, you know, midday or something, and then using the Phong model. And to do this, you will have to associate normals with each vertex of the terrain if you want to include diffuse and specular components. And of course that's making it more interesting because just having ambient is a bit boring. Setting normals is not that straightforward, so we basically provided you with one method below. You will find it on the links. So it's basically this one. So here you'll find that one. You're by no means stuck to using that. If you have your own method that you likes better or you find this a bit fussy, then you know, use something else. But it's a possibility, and I think it's been used quite a lot, so I think it should be quite simple. But it's a challenge to set these normals, of course. Right, and here's an important point. If you really struggle or don't have the possibility to render this terrain, there's an escape route, but this escape route of course is going to penalize you because it's much simpler. So if you have problems with this terrain, then you may generate a flat one, but then you have to really add on a lot of things to gain some sort of score of significance, to sort of make up for all the things you could put into this more general terrain. So, for example, be more advanced with making forests and make the ground look a bit more detailed. You could, for example, use something called normal maps to make the level of detail on the ground more interesting, and also the lighting. But note that with this option you can only get a 25% score on task 1 at most. But you will be able to additional points here if you include additional tasks, of course, as you would if you were capable of loading the terrain. But this is not something you should speculate in. It's basically an escape route if you really suffer from trying to render the terrain itself. Yes, I think, yeah. And you will also be penalized some on task 3 because one task there will become significantly easier if you have a flat terrain. Now, additional features here is to generate your own terrain, actually. That will give you quite some points if you're capable of that. If you have some ideas on how to do it, you might try that. Then, of course, you don't load the terrain from these resources. So if you have an idea on how to do that, you may try. If you have no idea and don't want to address it, then fine, don't think about that one. But it should not be easy. I mean, if you just load the flat terrain, that's not going to give you much. But if you have hills, valleys and lakes, like you see on these other height maps, then that could give you quite some score. So you have one or two options here. You either load a height map, that you have one of those you have provided, or you make your own. Additional feature, you can add shadows to the scene. You can render clouds. So if some of you heard about the skybox, that's one way of doing it. You can introduce rain or snow as additional features, and if you want to be some advanced, you can use something called particle systems. Now, in these additional features, there are things I haven't talked about in the lectures, and that's a bit of the point, because as I also mentioned below, you can go beyond this. It's possible to if you have some idea you would like to implement, you have the possibility to do that. Just make sure you explain that to us in this video or in the README file that you place along with your solution. So make sure that that's available at your repo. So questions to task 1? Okay. Then I'll pass on to task 2. It's moving cameras and lights. I think most of you will see known things here. So first and foremost, provide a free moving camera whose orientation is controlled by the mouse or these keys. It doesn't need to be exactly those, but keys of your choice. So it's also quite open here, or you can use both of them. And then of course switching between global camera, which is basically bird view seen from above, third person and first person perspectives. You may use the toggle button, for example, or another button you find convenient. But just make sure you explain to us the functionality if you use something else. And third-person perspective could follow or be locked onto one of the objects in task 3, if you like that. Another thing is, now we would like to see dynamic movement of the sunlight to produce a day-night cycle. So you of course have to let the sun move, and also change the lights throughout the day cycle. So for example, it can be white at midday, it can be yellow at evening, morning, and red, orange at dusk or dawn. But you're free also to choose colors here. We try to make it look a bit realistic. And at night, you could set the light to some dim ambient dark blue color, so the scene is still visible, or barely visible at least, or whatever choice you find moody here. Connected to this, there's also this additional feature where you can try to position different dim light sources throughout the terrain during the nighttime to make it more moody. So that's really up to you. You can gain some extra point by adding that. And then the last thing here is to emulate ripples or specular highlights on the water surface of the lake that is in this height map. And here you may use a normal mapping. I talked about this on the shadows lecture, so it's not something you've seen a lot, but it's basically a texture. So this is one way of obtaining these ripples. If you have a look at the resources again, you find two normal mappings, and both of these are sort of emulating ripples on the surface. So these are basically just textures with normals in them. And note that they are bluish, which means that they by default point in the positive C direction. So you have to do some transformations here if you want to put it on the ground, like in the XZ plane, instead of having them pointing in the C direction. And all this is explained under this link here, if you would like to use the normal mapping for this purpose. It looks quite advanced here because they look at it for general curved surfaces. In your case, it's quite simple because it's only on a flat plane, the lake. So the computation becomes somewhat simpler. Additional features. You can allow the user to control the speed of the day-night cycle using the GUI, in a similar way as we use the GUI for certain purposes back in Lab 5. You could integrate zooming functionality into the camera. You could add a minimap that shows the position of the terrain from above if you're in first-person perspective. As I said, you can try to position different dim light sources during the nighttime. You can also use the GUI to control these positions and the colors. And here, if you'd like, add sound to the whole landscape and make it change appropriately with the scene. Again, about how involved you make this will really determine what score you will get by these tasks. So that was task 2. Then task 3. Are there questions to task 2? Okay, then I'll move on to task 3. It's basically about objects, so you should load land, air and water-based objects to the scene. One of each, so it's 3 in total. You can add more if you'd like to. I provided quite some models in the resources. There's a moose, deer, duck, fish, eagle and a plane. And so you have 2 of each of these here. But of course you just load 1 of each. 1 airborne, 1 waterborne and 1 landborne object. So if you go here, you will find different ones. So 2 types of deer, 1 duck, 1 eagle, fish, moose, and a plane. So yeah, it should be, and yeah, an important thing, these are of different sizes and resolutions. I think this plane is quite low poly, just 307 kilobytes. 1 deer here is quite big, the other one is smaller. Let me see. Were there any questions? Yeah, in some of them there are. Not all of them, but some of them. So, and some of them have, so they're variety of files. Some have MTL files and these textures you can put on after you loaded the model. So some have both. Some have just MTL files, I think, like this pine tree. And then you have those who have just the possibility to load textures afterwards. But there should be a little bit of each here, so you just have to look through them and figure out. But I know some of them have only positive face values. No. I mean, as I say, it's up to you which one you pick. As I say, there are different resolutions, so you can pick one of a lower resolution. For For example, one of the deers is of a lower resolution than the other, if you pick one that has only positive values, or if you look online for other objects you would like to put into the scene, that's also fine, right? As long as they're sensible. So all we ask for here is you can use this file if you'd like to, or just make sure, or you can use your own. You can generate your own or find one online. But the point is that you load one land-based, one air-based, and one water-based object, basically. And try to make them sensible. For example, having a flying rabbit is a bit strange, but yeah. Otherwise, it's really up to you. You just provided some, so you have someone you can use if you don't want to spend your time in looking up these things. So here's a plane, for example, that you may load for the air-based one. And of course, fish and duck is for the lake, and then the deer are for the land-based ones. So pick one of your choice in Viking. No, I think that's. I think that, as I said before, everything you do on your own, of course, is a plus. But you're also free to use other programs, basically. But of course, as I say, for example, in the additional feature here, if you make your own object loader to load relevant objects, that's going to give you some additional points, right? But it's really open what you do here. So you have a lot of flexibility and possibility. Okay, so yeah, importantly, these models could move randomly around in their own element. So the air-based one, or for example, the land-based one would move around on the terrain floor. The air and water-based one can be confined to this two-dimensional surface that defines their elements. Like, for example, the air-based could just be a plain surface above the terrain where the plane or the eagle is moving. And the fish and or the duck can be confined to the water surface, for example, on the lake. As you'll see down in the additional features, you could add on to this and get extra points, for example, by letting the air-based model maneuver in 3 dimensions above the landscape, or you could let the fish jump in and out of the water, or the duck dive under the water. So make it more sort of like a 3-dimensional movement will then add on points. And this one is probably a bit demanding, but you should try to avoid that objects move through the ground, through the trees or other objects. So there's some sort of collision detection and those sort of things here. But you may allow them to, for example, partly sink into the water if you allow them to walk into the lake. You could also say that, for example, land-based models should not be allowed to walk into the lake. It's really up to you. And also note here that since this task becomes significantly simpler if you have chosen this alternative flat terrain in task 1, then you will have a 50% penalty here, right? So you will lose 50% if you, even if you implement this. And then last here, allow the user to switch between the different objects to obtain land view, bird view, and lake view. So in third-person perspective, you can lock it onto one of them and sort of get these views from different perspectives. And then also take control of them by using the mouse or the keys, right? And move them around at your will. Additional features, make your own object loader is a possibility. Yeah, so I already said you let the air-based model move in 3 dimensions. You can try to move the object systematically. What I mean here, by, for example, if you're in first-person perspective and you see a deer, that deer will naturally move away from you, something like that. Or you can make them very curious, so they all move towards you. I mean, it's really up to you. But if you make them move more intelligently, or even let several models interact here, that will give you some extra points. I already said if you can let the fish or the duck move in 3 dimensions in a way, that's going to give you some extra score. If you find the possibility to animate some suitable model, I say look for one online here, because I think the ones I provided is not really that easy to animate. If you're capable, that's of course very, very impressive, but you can look for one online if you would like to make some simpler animations. You could add sound that corresponds to these objects, and if that sort of like corresponds well, that will give you some extra points. And you can let the user choose between following the movement of the objects or control them at will. So for example, if the object is moving randomly or you have implemented this systematic movement, then the user could have the choice of just following it around. So that's the 3 tasks. Are there any questions to this before I move on to the rest? Okay, so I will then move on to just explain certain features that is important here, and you'll also of course have the possibility to ask questions after I'm done too about all this. So as I mentioned, additional features are there to basically add bonus points, but priority should be given to the main task, as I said under evaluation on the top of the document, that you should have to address 2 of them to pass, and you should address all 3 in order to get a good grade. Not necessarily completing them, but address them, so that you sort of get a composed solution here. It should be focused on the main tasks, but all these additionals are there to sort of give you a possibility to make up for things you couldn't solve in the main task. So there should be a lot of flexibility in that. Of course, also, if you would like to add extra points on one of the tasks over the other, then you have the possibility to implement it anyway, right? And you will get this bonus score. Also, yeah, the additional features are quite open-ended, so they can go beyond any ones we mentioned here. If you have some idea you would like to implement, that's fine. Just make sure you explain to us in the README file or in the video the things you added so that we are aware of them, right? And that's important, so we don't have to sit and test out all sorts of things to figure out what you may or may not have implemented. And of course that these additional features are weighted based on the challenge they impose. And also each and every one of them, you know, how complete you make them will of course determine how many points you get. Professionalism, this is the same as we've been mentioning throughout the course. So we expect a professional standard in your coding, and if you do that, that will always count in your favor, right? Also, if you do efficient rendering and those sort of things are very nice. So these will count for all tasks basically. But it's the same thing we've been saying in the assignments here. Also, when you deliver, it's important that we have this README file and that you should document your code so that we understand it more easily, and we should get instructed, you know, on how you use your application. You know, key bindings, debug functionality, description of additional features, and those sort of things. So you know, particularly if you choose additional features of your own. And this one is important. We expect more commits now. It says roughly 1 commit per hour here. It's just something I've taken from earlier exams, but it doesn't need to be exactly that, but there should be something. Because it's very hard for us to check whether or not, you know, you could have someone doing all this work for you and make the commit the last day. So we would like to see a track record on this. Right, and it's also sure to decrease the chance of you losing parts of your work, so make that happen. Then it's communication with the teaching team during the exam. Since an exam, we cannot sort of answer to how you solve different aspects, or you know, if you have troubles with the computers. But I already said it's very important that this is up and running. You can of course ask clarifying comments with regards to the exam, you know, like some of you have done now, if it's something you wonder about, and you know, these sort of things. And as I explained to you, you do that through the GitLab repository. And it's important that you include this exam label, as I said, and subscribe to it so that you get an email once it's addressed, because then you will also see when I answer to it, for example. Right. Yeah, this by direct emails is getting chaotic and difficult, and it's always nice that everybody gets to see what issues there may be here. So we avoid this one. There's some links. You have links on how you may set terrain normals here. There are other ways of doing this, so if you know about another method and you would like to use that, then feel free to do that. Here is a little bit about normal mappings, if you choose to use that to, for example, make ripples on the lake. The resources you have already seen, they're provided through this exam wiki page. You also find it at this URL here. Yeah, so I already said that you have different height maps, and you just choose the one that you prefer, basically, one location, and the resolution that fits your computer the best. Then is the deliveries, URL to the code repository, posted alongside your new username and the spreadsheet link from the course wiki page. I can just go through this again so we're certain about that. So in here, I'll just put this down. So here under the exam you have this spreadsheet, you click that one and you should get up this. So by your username, it's nice, someone has put it up already. Yes, this I encourage everybody to do. Encourage everybody to find their username, put up their repo here at once, and then check if it works, make sure we have access, at least before the deadline, because all you need to do on the deadline is of course then to just make the last commit. And yeah, there's a link to the video here, as I said in the beginning. So that's it. That's also the same thing I say here. Consider making a repo, and place its link into the spreadsheet as soon as possible, and make sure that it works. Then after, let me see. Okay. What's the problem? Eric, did you have any question or? Yeah, I mean that should be fine. Sure. Okay. No. Yeah. So I think it's as long as there's something available there over time. I mean, whatever how you choose to. Yeah, I mean, this thing shouldn't get in the way. So, do whatever you need to do to make it run. And make sure that we have access to it afterwards, then, yeah. Yeah, that should be fine. I'm not sure I get you. Yeah, I mean, what we would like to see is a track record, basically. So I think that yeah, it's okay. I think it's easier if you spoke and just ask the question directly. Okay, I'll just wrap up and we can take questions towards the end. Right, so just to finish this up, okay, so you already seen this one now. After you're done with this on Thursday at noon, you will have another 12 hours to fill in this self-assessment form. You already seen it, so you find it here. You click this one, and you basically answer to how you're able to address the exam task, basically. And then you evaluate the exam at the end, and then click send. So it's done in you know, half an hour. But just make sure you do that within those next 12 hours. Okay, and yep. Let me see. Yeah, I mean, if that's what he meant, yeah, sure, of course. That's what I've been saying through that. Study your framework and make sure that it's up and running. So yeah, you're free to do that. If that's what he meant, yeah. Yeah, sure, of course. That's that's a bit of a deal. Use it as a groundwork. You don't have to. I mean, everything you can reuse here is fine. Just fine. So. I mean that's sort of like lying beneath for this exam as well. There's a lot of tasks you've been looking into already, and feel free to reuse those parts. That's yeah, definitely something we expect. Otherwise, this can become quite difficult. Okay, so after you have filled in the assessment form, yeah, thanks by the way for explaining it. Okay. I mean, that's really up to you, basically. Okay, lastly, video or exam. This we expect you to deliver over the weekend, so by Monday 2020 at noon. Sorry, Monday 25th of May at noon is when we expect you to have that. And there you have the possibility to highlight the functionality and really show us what you've been doing. You know, make sure to get all the interesting things forward so that we see that. So a 3-minute long video where you are basically displaying all these functionalities and how it works, walking through it basically. A little bit like you did on the assignments, only a short version of it. And it should be hosted on some video hosting platform. And then again, you provide us the link in you know, alongside your project here. So I think that's it. I think I went through all I needed to say. So basically there's half an hour until the exam officially starts. So if you have questions, feel free to ask them. I have the possibility to do that. Those of you who would like to start, you can start at once. So yeah, you don't have to wait until 12. No, you don't need to do that, basically. It's up to you. The video doesn't need to have speech now. I've seen several solutions there. Some is just playing through, someone adds music, you know, if you have sounds on the corresponding to this model of yours, then someone just playing that one. So, but you don't need to speak. Just make sure that you illustrate things clearly. Yeah, this is, yes, you use the one in the exam document, because actually this is, 21st is a holiday, and they have put off like 72 hours, to get those 72 hours we need to go into the 21st, otherwise I would have to have gone through this task yesterday for you, so that's why we have done it that way. But yeah, 21st. So Studentab is just a default that will there. It's not required. It's of course nice to do so, but it's not required, no. If you don't do that, then you make sure you explain to us how to compile things, so that we don't have to use a lot of time on that. If we have a hard time making it run, it's very hard for us to assess it. But idly, yes. But yeah, otherwise you have to really explain it thoroughly, whatever you choose to do. Other questions? I think that, yeah, there's someone with Linux, so if I mean, you shouldn't really use your time on this operating system problem. So sure, we can manage that. Of course, the best thing would be if it worked on all of them, thereby the CMake thing. But yeah, that shouldn't. I mean, if it's the solution that you present that really matters, so if we have someone to do that. Other questions? Anyone had trouble loading it? You could also mention that now. Or downloading the files. Okay, great. Okay, so just a little bit about the process. Just read through everything neatly. Make sure to get enough sleep, particularly in the beginning. If you want to stay up one night, then you know, speculate to do that the last one instead of the first one, because that may just mess things up. Do planning in the beginning and identify what you definitely can do, what you may be able to do with some work, and what you think you will not be able to do, so that you don't spend your time on trying to you know, don't get stuck with tasks so that you waste your time trying to solve them instead of those you can. So make sure you get to show us everything you're capable of here. It's quite a lot, so I think it should be a possibility for everybody who's been working throughout this course to pass it. And I also think that someone should be able to climb all the way up. And of course, if some tasks are so hard here that no one has been able to solve or just, then of course that will be taken into account when we censor this exam as well. No, you're not obliged to. It's like it's a guideline. This is something I've taken from earlier exams. So it's just to say we like to see commits often, but we don't want you to sit and commit and commit and commit. So it shouldn't bother you, the fact that you haven't committed one hour or the other. So yeah, but you know, more often than once a day, but perhaps not as often as every hour. Okay, so start off by planning and identifying these things, and do some research also, because there's a lot of tutorials and documents out there you can use to understand how you do these things, because it's task that's been solved quite many times before, so you'll find resources online. But of course we would like to see your own touch to this and your own solution to this. As I mentioned, having your own solutions to things is always going to count in a positive direction. So And of course remember that this should also be presented on the oral exam, so half of it will be your presentation and the next half will be about questions regarding course content. So you have the possibility to also gain some points there. Yeah, sure.
Hello, can you hear me?
I can hear you.
My question was, when we're doing the exam and we can't finish something, but then we manage to finish it by the oral exam, if we present it, will that give us some points, saying like, okay, this is what we meant to do and we managed to finish it by now?
Well, it won't give you points on this take-home component because that's basically what you deliver on noon that day. But of course you can argue to us how close you were and those sort of things, and we will see what we can take into account. But the oral exam will be more about how you present your solution, how you're capable of answering to questions we may have regarding your code, and also the course content. So, but adding points will not be possible now. But you're of course free to present it. If you would like to tell us how close you were or how far away you were from some problem, then that's very important to identify. Some more questions? I will be sitting around here in Collaborate Ultra with my headset on until 12. If you want to just start working on this, then feel free to do that. And raise your hand and notify me if you have more questions regarding this before 12. And I will try to be available here. And for those of you who choose to leave and start before, I wish you good luck with this. It may maybe seem a bit overwhelming, but it shouldn't be that bad once you get to look through it and identify these things. So try to always emphasize on what you can solve instead of what you can't, to sort of cheer yourself up. It depends a bit. You see that the one, for example, from Gjøvik, so it depends on the difference between lowest and highest level. So if I go into that file, you can see Gjøvik, for example. It goes from the lake and up to the highest hills here, which is maybe about, in this picture, roughly 500 meters. So from about 180 to 500 meters. This map is more extreme. It goes from sea level up to about 900 meters. So you see that you go from a lower to a higher. So it really depends on the profile here. And as I say, choose one of your liking here, depending on what you find most convenient for the solution you have in mind. Because it's important that you imagine some solution to this, right? And then you pick the one you sort of find fits the best. So you see you have different altitudes, right? That is one thing. Some more steeper hills, some softer hills. You also have more emphasis on the lake in some of them. Like here it's quite little, here it's quite a lot. Here it's covering, towards the end of the or the corner of the landscape, and here it's filling quite a lot in the middle. So there's a lot of options. Or as I said, you may generate your own, basically. And then you decide how big the difference should be. But it doesn't, as I said, it's very important, it doesn't need to correspond to the actual levels here. Feel free to scale them up and down at your will, basically, once you've chosen the map. Okay, good. It's enough that you add me as a member. But I mean, it doesn't really matter if it's public either, in the sense that I guess that's only I don't know, that will probably only be visible for people who has the link anyway, right? But it's enough that I get access to it, basically. So it's a bit up to you. If you would like to make it public, then yeah, okay. Okay, so I'll stop sharing the screen now, but I'll be around until 12. So just send messages or turn on the microphone and speak if you have any further questions, and I will be happy to try to answer them. So let me show you. So if I pick this one, for example. Now you have pixels, a pixel grid, which will correspond to X, Y in this image, but in the terrain you will let them correspond to XC, for example. And then the elevation level here is basically the Y value in the, if you look at with respect to the OpenGL coordinate system. Oh, sorry. Yeah, I turned my microphone off. That was yeah. Okay, I'll explain again. No, yeah. No, it's not flat. I mean, it's if you look at this one, what you basically have are three. At each point, you have three coordinates, right? So you have X, Y, and then C is towards you. But you have to make sure that this will relate to the OpenGL coordinate system as you know, XC, and then the Y component will sort of like be the height level. So it's not flat. So the point is, if you had troubles with this one, then you should just have a flat terrain and try to make it more involved, right? But the point is here that you have something that moves up in the Y direction depending on these values. Did that answer your question? So it's basically just making a mesh from this image with vertices, and each vertex has x, y, and z coordinates, where the y coordinate will correspond to the grayscale level. So it's something you had done before, just a bit more involved. And of course, important. I made this here as an escape route. Now one shouldn't choose that as a default because you will get a really low score if you do it. And as we ask you to address all 3 tasks in able to get a good grade, one should not speculate in it in a sense. But it's just an escape route, so it doesn't mess up the rest for you. If this becomes very difficult, you have the possibility to sort of solve many of the other tasks with this 25% score if you make it involved enough, basically.